Hey fellow coders, in this series we're going to talk about some common technical interview problems that interviewers like to ask. Today we have a string problem that is, given a string, determine if a permutation is a palindrome. What is a permutation? Well, that is just a recombination of the characters of a string. And a palindrome is a string that is the same forwards and backwards. So, for example, for this string AAC, there is a permutation of that, which is a palindrome. In this case, this is that permutation. ACA is the same forwards and backwards. Another example would be this string. A permutation of the string that is a palindrome would be this. So as you can see, in a palindrome, you have every character that is either in a pair or there is one character in the middle that does not have a pair. So let's go ahead and solve this problem. Now, you might want to ask the interviewer for confirmation on whether characters like spaces or slashes count towards being a palindrome. In this case, we're just going to say that spaces and special characters don't count. A string has a permutation which is a palindrome if each character in it appears as a pair, except one. Now what does that mean? For example, the string CACA has two pairs, one pair of C's and one pair of A's. Therefore, we know that there is a permutation of the string that is a palindrome. For example, that's a palindrome, and that is a permutation of the string. However, this string, AAC, has one pair and one character that can be in the middle of a permutation, which also forms a palindrome. So, detecting for these two cases will allow us to find which strings has a permutation that is a palindrome. There's a more efficient approach which uses a hash set to record the characters which we've seen before. And as you know, if we've seen that character before, we can know whether or not that there is a pair of these characters or not. So here's an example. In this string, we'll go through the first character R, and then we'll assume that there is no pair. There's only one R, so the unpaired characters is 1 until we find another R. So R, and then we've never seen R before, so let's record this in a hash set. R is here. Okay. Next character, O. We've never seen that character before. I'm going to increment the number of characters that isn't a pair to 2. We'll record O in the hash set. Next character is O. Now we actually have seen that character before, so we will remove it from the hash set. And since that there is a pair, we'll reduce this number by 1. So there's only one character which doesn't appear as a pair so far. So we can move on to the next character, T. We've never seen this character before. We'll add it to the hash set. and then we'll increment this by 1. We can go on to the next character, a space, and in this case we don't count spaces, so we'll just move on to the next character, which is an A. And we look in the hash set, we haven't seen that before. I'm going to add that in. And now that there isn't a pair, we'll increment this as well, so 3. And then we can move on to the next character, R. We've seen this character before in the hash set. We can remove it and decrement this, 2. And finally, T. We've seen this character before. Remove it from the hash set. Decreases by 1. And as you can see at the end of the string, one run of the string, we have this number which we can use to determine whether or not it has a permutation, which is a palindrome. And in this case, because this number is not greater than 1, this string does indeed have a permutation, which is a palindrome. So we can return true. So once we have our approach, we can start coding. We'll define a function that returns a Boolean for whether or not the string has a permutation of a palindrome. Boolean. And we'll call it has permutation of palindrome. And it'll take a string as an argument, and we'll call that string S. And the first thing we need to keep track of the number of non-pairs. As we talked about earlier, this number has to be less than or equal to 1 by the end of the method. So we'll call it non-pair equals 0. We'll also need a hash set to keep track of the number of character pairs. And we'll call it set for simplicity. Go new hash set character. Okay. So now we can iterate through the string. I less than s dot length I plus plus. So we want to get the current character at index I, current car is equal to, now depending on whether the interviewer asked for a non-case sensitive matching, you may want to do this, which is get the lowercase variant of the character dot to lowercase of s dot car at I. This will give you the lowercase character when you're doing the matching. Now we want to check whether or not that character is an alphabet. And if it isn't an alphabet, we want to skip it. So if not, character dot is alphabetic. current car. We'll just continue the loop, and we'll skip this character. Now we can check whether this current character is in our hash set. So if it's not in the set, not set dot contains current car, we'll add it to the character set. Set dot add current car, and we'll increment the number of non-pairs. Non-pair plus. Now otherwise, if the character was already in the set, we want to remove it from the set. Remove current car, and then decrement the number of non-pairs. And finally, we will return whether or not non-pair is less than or equal to 1. Remember, if it's greater than 1, that means there are characters in the string s that don't have a pair, and there's more than one of these characters, which it's impossible to form a palindrome of using a permutation. And that's it. This is the function that will solve that problem. And this approach uses O of n time complexity. And you can see that because it iterates through the string once, and where n is the number of characters in the string, and it can determine non-pair, which is used to see whether or not that string has a palindrome as one of its permutations. And in terms of space complexity, we used a hash set to record the characters as we go along. And this, depending on your interviewer, and if you're using ASCII character set, it could be O of 128, since there can only be 128 different characters in the set, and therefore you're only using O128, which is really O constant space complexity. But if you're using something else like Unicode or some other character set, this would be whatever, however many different characters there are in that set. And that's it. So hopefully this was helpful to some of you, and if you guys have any questions that you'd like answered, just let me know in the comments. And if you like this video, please like and subscribe, and have a good day. Thanks.